Good afternoon, students. Myself, Dr. R. Logesh Babu, Assistant Professor, Department of CSBS. Today, in Unit 3 Machine Learning Essentials, we are going to see the topic on logistic regression. So, from the definition perspective, it is nothing but a logistic regression is a statistical technique where it is describing the and explaining the relationship between one dependent variable, nothing but a y, and one or more independent variables, nothing but a x1, x2, x3, etc. So generally, how we are representing the values through this? So generally, in order to represent the variables and its value, we are taking the categorical variable which can take maximum of two possible values, which is nothing binary values, either two values, either one to represent 1 and 0. So we can say in notations, we can say y represents, if y equal to 1, it represents the success, whereas y equal to 0 represents the failure. So how we are differentiating from the logistic regression from the linear regression? So in linear regression, we are fitting the straight line in linear way. So that is the generally we are plotting in the graph. Whereas in the logistic regression, we are fitting a regression line. Instead of fitting a regression line, we are fitting a S-shaped logistic function which can take the maximum of values 0 or 1. So from the graph, we can able to see where x represents the independent variables, x represents the independent variable, where y represents the dependent variable. So the value should be maximum of ranges from 0 to 1, 0.0 to 1. And the curve also, what we are plotting is called also looks like in the S shape through the plotting points which are plotting the points on the graph. So what are the examples we can say comes under the category of logistic regression? So generally it will be used for classification. So in that case, whether we can able to find out by doing the experiments, from the data set we can able to identify or classify, then classify the cells are cancerous or not, the mouse is OPSI or not, etc. Right. So what will happen when I am giving the new data sets? Whenever I am giving the new data sets, it is also able to classify, in a position to classify for both continuous and non-continuous values. That is, discrete values and continuous values also has to be classified. So what is the mathematical function used in this model? So the mathematical function used to map the function is called the sigmoid function, where it will map the predicted values to the probability values. So the probability values should be from we already seen, it will be the range of 0 and 1 only. So and maximum of the limit is 0 to 1, and the curve also should be in the form of S shape that we have seen already. So where it is used, the logistic regression used when the dependent variable is binary or dichotomous. What is meant by dichotomous? So it is called, the meaning is divided into two distinct parts. So it will have maximum of two values. It will have two values only, two values in the range for used for classification. So what will be the values will be, it will be because of it is a binary variable in nature, the classification will be either yes or no, or default or no default, or responder or not responder, etc. So the independent variables can be categorical or numerical values. So now how we are representing through the mathematical equation, we can see. So generally the logistic regression equation will be y equal to b0 plus b1 into x1 plus b2 into x2 up to bn xn. So these are, so generally, but in the statistical representation, I want to dependent variable y should not exceed 0 and 1. So I am dividing it by 1 by minus y. So if I am dividing it by y, 1 by minus y, so what I am getting, when it will become 0, when y equal to 0. And similarly, for it will become, the value become infinity when y equal to 1. This is the value we are getting for initial logistic regression equation. But if I am needing the need of the value from minus infinity to plus infinity, what I have to do? I have to take the logarithm of the equation. So what will it will become? If I am taking logarithm, it will become log y by 1 minus y equal to b naught plus b1 into xn up to bn xn. So how the sigmoid function look like as the outcome? So it can able to map the any predicted values to the probability values in the range of 0 and 1. The equation will be sigma of z divided by 1 plus e power minus z, and the curves also will be in the form of S shape. So these are all the equation we are getting after finding out the values through linear model, sigmoid function, as well as logistic regression model. So now we can able to, through this graph, we can able to differentiate between linear regression as well as logistic regression. From the linear regression point of view, the values we can able to see the plotted line will looks like linear, corresponding to x and y values, and the values also exceeding 0 and 1. Whereas in the logistic regression, the value is plotted between dependent and independent variable does not exceed the range from 0.0 to 1.0. The predicted values lies always with 0 and 1 range, and we are getting the S shape also. We are getting the curve in the form of S shape. Now we are going to move about the how we are doing the evaluation using the confusion matrix. So what the confusion matrix? It will be a table which will shows the performance, how we are the particular logistic model performing for the by comparing its predictions as well as the actual outputs. So we are classifying the outputs as into 4 categories for the correct predictions with the true positive and true negatives, as well as in incorrect predictions for false positive and false negatives. So whenever I am not getting the accuracy, expected accuracy, by seeing this table I can able to find out the errors, so that I can by fine tuning it I can improve the performance of through the parameters. So how the table will be? So the table will be the plotted between actual values and predicted values. So the green color which are highlighted as called the true positive and true negative, whereas this side for FP for false positive and false negative. The false positive is called the type 1 error. So it will, that is, it indicates the predicted value is positive but it is false. Similarly for type 2 error, so the predicted value is negative but it is actually positive. So what are the metrics or formulas or accurate performance measures we are using for this logistic regression? There are accuracy, precision, recall, F1 score, false positive rate, that is called the type 1 error, false negative rate, that is called the type 2 error. Now we are going to see one mathematical example for understanding this confusion matrix. So where the accuracy will be plotted as true positive plus true negative divided by true positive, true negative plus false positive plus false negative. Nothing but correct predictions divided by the total predictions. From the diagram you can able to we are calculating the value as 6 plus 11 divided by 2 plus 1. Totally we are getting the accuracy as 85%. Similarly, for precision, that is true positive, actual positive values divided by total positive, predicted positive. So we are getting from the values given, we are predicting the precision as 75%. For the similarly recall also, it will be 85%, and F1 score we are getting as 79%. So we can able to improve by seeing this confusion matrix. Thank you.